Okay, Chapter 2, Section 1, we are going to learn about transformations of quadratic functions. So transformations are just how the graph is moving. So we would take just our basic quadratic function, and some transformations are going to happen to it. So we're going to shift it, we're going to stretch it and condense it. We're going to do a whole bunch of stuff. So there's a lot of vocab in this sections. This section's very vocab heavy, so if you need to, you can make flashcards and kind of help you remember all the different transformations. In example 1 or exploration 1, we're going to be identifying graphs of quadratic functions. So here we just want to match each graph with the function and explain the reasoning. So it would be helpful to look at each function we have. Since they're all in vertex form, we can just identify the vertex. So our vertex form is y is equal to a times x minus h squared plus k. So it's what we're adding inside and what we're adding outside to find our vertex, which is h comma k. And don't forget, we always change the sign of what we're adding inside. We always change the sign of h. So our vertex for A would be 2, 0, because we're adding, well, negative 2 on the inside. We change the sign, it becomes positive 2. We're not adding anything on the outside, so that's where that 0 comes from. So I'm going to look at all of my graphs and see which one goes to the right 2 and stays on 0. The only two possible options would be B and D, but one of them opens up and the other one opens down. So then I want to see, what's my A? Is A positive? Is A negative? A would be negative, so that tells us it opens down. So my option is D. So this would be A. A and D go together. I guess I can match it this way. There we go. All right, next let's look at B. So my vertex for B would be 2, 2. Remember, we changed the sign of h. So I'm going to look at my graphs. Which one has the vertex at 2, 2? So I'm going to go to the right 2 and up 2. That would be C. Any other possibilities? Nope, just C. So B goes with C. Next, we're going to look at C. My vertex here would be negative 2, negative 2. So which one goes to the left 2 and down 2? That would be A, and that's the only one. So C would go with A. Next, for D, my vertex here is positive 2, negative 2. So we got to see which graph do we go to the right 2 and down 2. That would be F. And that's the only one that goes to the right 2 and down 2. So D goes with F. Next, for E, my vertex here would be positive 2, 0, because I'm not adding anything on the outside. So 2, 0. The only one left that has a point at 2, 0 would be B. So E goes with B. And then lastly, we know F is going to go with E, the only two that are left. But let's figure out what our vertex is anyways. So my vertex would be negative 2, positive 2, because we changed the sign of H, and we know it's going to open down. And that matches perfectly with the last one we have left, which is E. On the next slide, we're going to be describing transformations of quadratic functions. So here's just some vocab, which we already know. A quadratic function is a parabola-shaped graph. So parabola just means that it is U-shaped. We can either have a parabola that opens up or down. So U, or upside down U. In vertex form, we have this equation here, where vertex is h and k. The vertex is either the lowest point or the highest point of our parabola. Again, vertex form is written here. And then down below, it describes transformations. So A, the number that we multiply out front, indicates a reflection in the x-axis and or a vertical stretch or shrink. So if A is negative, then we have a reflection. In the x-axis. If A is a number that's greater than 1, so it would have to be greater than 1, then we have a vertical stretch. And if it is a fraction or decimal, so something in between 1 and 0, so it would be in between 1 and 0, which means it would be either a fraction or a decimal. Something that is less than 1, then we would have a shrink. Just think if it's a smaller number, it's shrinking. If it's a big number, then we're stretching. Whatever we are subtracting on the inside, we have a horizontal translation. So if we are subtracting a number, that tells us that we are moving to the right. If we are adding a number, we're moving to the left. So the number on the inside tells us if we're moving left or right, so we're moving horizontally. And then the number on the outside indicates a vertical translation. So if we add something, we're going up, and if we subtract something, we are going down. So these are all our different types of transformations. We have a reflection, stretch, shrink, left, right, up, or down. On the next slide, it talks about our shifts. So we can have a horizontal translation if we are adding something on the inside. So we'd add something inside of the parentheses. That tells us if we move left or right. Again, if we are adding, we go to the left. If we are subtracting, we go to the right. We have vertical translations when we add something on the outside, so whatever our K is. If we are adding something, we go up. If we are subtracting something, we go down. So we're going to look at an example. So here we have to describe the transformation of just x squared represented by x plus 4 squared minus 1, then graph the function. So our basic graph, just x squared, starts at 0, 0, and it's just a normal parabola. Nothing special. Now we're going to take that graph and shift it, whatever transformations we have happening here. So first we want to look at the plus 4 on the inside. When we are adding 4 inside the parentheses, that tells us we are moving to the left 4 units. So I would take my graph and shift it to the left 4 units. So instead of being at 0, I would move to the left 1, 2, 3, 4. Now I also am subtracting 1 on the outside, so that tells me I am going down 1 unit. So not only do I move to the left 4 units, I also go down 1. So now my vertex, instead of being at 0, 0, I had to move it to the left 4 and down 1, and then my graph just keeps that same shape, like that. So we just take our graph and move it to the left 4, down 1. So it is very important that you know your transformations. You have to have those transformations memorized. If you need to, make flashcards so you know what direction your graph is moving. So on the next slide, we're going to describe the transformations here. So when we subtract 3 on the inside, that tells us we are moving to the right 3 units. All we're going to do on this page is describe the transformations. We don't have to graph them. On number 2, when I subtract something inside the parentheses, that tells me I'm going to the right 2 units. And then when I subtract something on the outside, I'm going down 2 units. And then for number 3, adding something on the inside tells me I go to the left 5. And then adding something on the outside tells me I'm going up 1. All right, so I have 3 more types of transformations. When we have a negative being multiplied on the outside of our parentheses, when we have like y equals negative, it'll be x plus something squared plus another number. The negative on the outside tells us we have a reflection on the x-axis. That would be a reflection on the x-axis. Negative means reflection. Just flips our graph upside down. We know when A is negative, our graph opens down, which basically comes from having a reflection. If our negative is on the inside, so let's say I have y equals, and then in parentheses, negative x plus a number squared plus another number on the outside. When your reflection is on the inside, when the negative is on the inside, it is a reflection on the y-axis. So one easy way to remember if you're reflecting on the x-axis or the y-axis would be you always want to keep your ex-boyfriend outside the house. So if you have a negative outside the parentheses, that's on the x-axis. So think your x's stay outside of your house. You don't let the x's inside the house. So if you have a negative on the outside, it's a reflection on the x-axis. All right, last one is a vertical stretch or shrink. So that's when we're multiplying a number outside the parentheses. It'll be like our a. So if I had, let's say, 2 times x plus whatever squared, that 2 would mean I have a stretch. Because we have a vertical stretch when a is greater than 1. And then I have a vertical shrink when a is in between 0 and 1. So if I had something like 1/2 times x plus a number squared, that would be a shrink. So think if your number is smaller than 1, you're shrinking. If the number is bigger than 1, you're stretching. Right, for example 2, we're going to describe our transformations. So when I have a negative being multiplied on the outside, that's a reflection. And since it's outside the x, it's not inside the parentheses there. We don't have parentheses, it's outside. That means it's a reflection on the x-axis. And then when I multiply by 1/2, since 1/2 is less than 1, that would be a shrink. Now let's look at B. So multiplying my x by 2, since 2 is greater than 1, that is a stretch. And then when I'm adding 1, this 1 is not inside parentheses, it's on the outside, so that means I'm going up 1 unit. For number 4, I'm multiplying by a fraction, so this would be a shrink. For number 5, I'm multiplying by a whole number, a number greater than 1, so this would be a stretch. And then I'm subtracting 1 on the inside, so when it's on the inside, we're moving horizontally. When you subtract, that means we're going to the right. So we're going to the right 1 unit. And then for number 6, multiplying by a negative on the outside is a reflection on the x-axis. When I add 3 on the inside, adding on the inside means we go to the left. And then adding on the outside, we're going up. So up 2 units. All right, that's it for the notes. Don't forget to turn in the notes by the end of class. And once you turn in the notes, you can go ahead and get started on the homework.